Hi friends, today I'm training on a new kata. It's shortest code series, planting tree. In this kata you are limited to 50 characters and your goal is to return a number of trees that can be planted given the length and the width of your real estate lot. The third parameter is gaps, and what it means is how wide the gaps between the trees have to be. So you can, it's not very easy to explain what how that will work, but let's try some examples. So first example, we have a lot of width equals 3 and length equals 3. So we have 1, 2, 3 here, 1, 2, 3 here. The O's represent trees and the dashes represent gaps. So we have one tree, then a gap, then tree again, then a gap, then tree again, gap, tree again, and gap again. And we form a perfect symmetrical lot with trees on the perimeter. So given these parameters, the function should return 4 because there can be 4 trees. Example number 2, we have a huge gaps. We have the same lot size, but the gaps are 3 now. So there's a tree, 1 to 3 gaps, then tree again, and then 3 gaps again. The third example is incorrect one. Look what happens. We have 1, 2, we have a tree, then we have 2 gaps, then we have a tree again, and it can't work more because it won't be symmetrical. Okay, so it just cannot should return 0 basically. So if it's not proper tree, if you cannot really plant your trees in a symmetrical way, you should return 0. And this is a large example, 7 by 7 and with gaps of 3. So we have 3 gaps, 3 gaps, 3 gaps. Then if you have one tree here, that's basically guaranteed that it's gonna be symmetrical, and you have 3 gaps, 3 gaps, 3 gaps. So that's perfect. What happens if there are no gaps? Basically you just plant a lot of trees. that's it. So we have 6 tests, and these tests are gonna help us, but we are not going to rewrite them. Let's move straight to the actual solution. And as always, delete everything, start with this basic premise, WLG. That's width, length, and gaps. And first of all, let's think about it a little bit. It is, if you would draw that on a piece of paper, you would very quickly notice that basically it's just, you can imagine that as just one, not necessarily a perimeter, but as one long line of trees. Okay, ignore these bends, and so this one long line then can be divided by gaps, and that these number of gaps will give you the number of trees with some modifications. The thing is that since you're given width and length, those kind of overlap twice, so you have to subtract something from it. Okay, so I'm going to just create a variable x and start with width plus length minus 2 and times 2. So that gives me, if you would think about it, that gives me the full length, right? The full, if that would be in one line, that would give me the full length. Then I'm dividing it by gaps, so new variable y is x divided by g, but it's not like net g, it's actually g plus 1. Why g plus 1? Well, think about it. If you divide, if g is like 1, that's actually there is one gap, so that means every 2 it should repeat, right? Every 2 steps it should repeat. But if that g would be 1, it would repeat every single step. So g has to be, you basically have to take into account not only the gap but also the tree before the gap, right? So that one is actually the tree. Finally, you're returning y, but what happens if it's not symmetrical, right? What happens if you cannot make it symmetrical? Well, luckily, if you would try to just return y, let's see what we get. Okay, let's try to return y and let's see what we get. So first of all, the first test has passed, second test has passed, third test, expected 0, but we got 2.66666. Right? That's okay. Let's leave it. The rest of the tests have passed, except for the last one, which again it expected to be 0, but we got 0.727272. So what you noticed, probably at least I noticed, that indication that it's not symmetrical is given that if it's not a whole, like if it's not an integer, if it's a real number, then that means it's not symmetrical. So if it has decimal numbers, if it's not equally divisible by that g plus 1. Okay, so to check that, in a rather easy way, I'm returning y using this modulus operator, and if that is true, if that's true, let's think about it. Then would that be true? Only then I have some like numbers in a decimal place. So then I return 0. All the other cases I return y. And let's try to run examples. Okay, all 6 tests have passed. Let's try the official solution. And let's wait for it. And 106 tests have passed, but 1 has failed. And this one is the code length. Basically, my code is too long because we are limited to 6 to 50 characters, and we actually use 72. Let's try to compress our code a little bit. So first, like immediately, what I see is I can replace this x right here with this, just inline it. Okay, let's see if that did the trick. Okay, it helped, but didn't solve everything. It helped. Now it's 61. Okay, so 11 more characters. Let's think about it even more. How can we do this assignment? Like, how can we avoid this return statement so long? It's so useless. And also, if we would do that in one line, we could save a few keystrokes on right here and right here. You might be thinking, okay, so just delete const here and const there, and you're basically done. But I prefer, keep my consts. I like to have my code clean. Let's no globals. Okay, let's try to think of a smarter solution. One idea which I have is, you can have default parameters, all right? And in these default parameters, you can use other parameters. Okay, so what happens if I would move my y right here? It would still totally work, and I could have access to this y right there. Okay, so if now I do something like that, that should work. Let's try that. And looks like my code is short enough. It's 44 characters. So that's one of the tricks how to save some keystrokes. You might be thinking, okay, so you're polluting your this argument space, right? But actually what happens is your function, whenever somebody is calling your function, we don't even pass the fourth parameter. You're just adding a new one, okay? And if somebody would say, okay, so I want to extend it, so that's very easy. You extend it like that. And also that gives you an option if sometimes let's say you know how long it is, you don't want to calculate it, you don't want to waste your time. Maybe that's very expensive calculation. Imagine this is like super expensive calculation, and you just happen to know it from some let's say API gives you like one out of 5 APIs gives you this number, and you can just immediately use it. You save your some computer cycles on that. So that's, in my opinion, is the best approach. There are alternatives. You can basically do assignment right here, just wrap it in parentheses and then use whatever you assigned later in the code. I don't find that specific approach to be very clean. I prefer this one. So I hope that you learned something, and see you in the next kata. Bye, friends.